We need an intro for the show, right? You are a podcast host. You love tech topics.
Geoff, what are you doing?
I'm prompting. Create an intro for today's show. Oh, and make it sound like a fun fair announcer.
Does that mean we're using an AI chatbot for this? Geoff, I'm kind of having my doubts right now.
Here we go. Ladies and gentlemen, boys and girls, and tech enthusiasts of all ages, welcome to the dazzling, the dynamic, the downright delightful From Know-How to Wow. Hold on to your headphones, because today we're diving headfirst into a whirlwind of wonders from AI innovations that will knock your virtual socks off. So, power up, tune in, and prepare to be wowed as we launch into a journey of discovery and laughter. Let the wonders begin. What? I thought that was pretty good.
Yeah, but it's not really our style, is it? I don't think an AI can match us just yet.
Maybe not match us, but it can help improve what we do, including our engineering solutions.
And today, that's just what we're going to talk about. We're exploring how large language models and other foundation models can be applied in driving a car.
That's great. That wasn't too bad of an intro after all, right?
Ever the optimist.
From know-how to wow. The Bosch Global Podcast.
So, generative AI has fantastic potential. Across all industries, it inspires people to find out what it can do for them. So naturally, as Bosch is the world's largest automotive supplier, the question came up: can generative AI improve vehicles, enhance the driving experience, potentially take some load off the driver? And I can't think of anyone better to answer these questions than our very own Bosch Research expert, Liu Ren.
My name is Liu Ren. I'm currently the Vice President and Chief Scientist located in Silicon Valley. And also I have a research team here also working on this kind of topic.
I know Leo. Longtime listeners of the podcast should remember him also. He was one of our very first guests on the show. If you missed it, check out the episode on visual analytics from actually almost exactly 3 years ago. We put the link in the show notes.
He's such a genius, and a lot has changed since that episode, though.
For sure. Today, AI is on a whole nother level. And that's because large language models, or LLMs, have become extremely powerful.
And just like the two of us, Liu uses them frequently as well.
So I use it quite often for my work, right? You can use it for write emails. You can just put in some key points, and then you can generate the emails.
There you have it, boosting both productivity and quality with generative AI.
Right, for low-stakes, text-based office tasks. But we were interested in what We were interested in what Oh my God!
Langsam.
We were interested in what LLMs can achieve in vehicles. And at first, that might not seem like such a great idea.
This could be very problematic because for driving, we want to have reliable, consistent, and also high quality kind of output there. And also one of the critical issues for the large language model is when they generate the text, they could have this thing called hallucination kind of effects.
That's something we all learned quite quickly. You can't fully trust these things. Generative AI has the potential to generate output that doesn't have any factual basis.
And that's definitely not something you want to introduce into a safety-critical environment like a car.
Driving is different from like just writing an email, right? Writing an email is not safe-critical. And, maybe we're using some kind of chatbot generate this text there. It's not perfect. I can just go back and ask the system to do it again, right? And for the driving, you don't want to make mistake, right? So it does not allow you to go back to, keep trying and error, right? This is the fundamental difference.
Another issue is that language has a high variability, You can say the same thing in many different ways.
In office applications, that is one of the strengths of generative AI, right? The same prompt can lead to different outputs. That's great when using it to write emails, like Liu apparently does, without sounding like a robot or reusing the same blocks of text over and over and over again. It feels natural.
But how do you marry that with automotive systems that rely on precise information about the environment?
Instruct the language system to generate structured kind of output with some kind of reliability and robustness. That sometimes is not an easy task. While it's exactly what we need for a lot of the automotive applications like ADAS, like even automated driving and all these, right? So that's exactly the research challenge we have to address.
ADAS, as you might remember, listeners, is short for Advanced Driver's Assistance Systems.
Another reference to our extensive back catalog of episodes.
And obviously to my all-time favorite episode where we featured ADAS for motorcycles. So again, very cool technology. But of course, ADAS for cars is cool as well.
And just to remind everyone, those are systems like lane keeping assistant, parking assistant, or automated speed and distance control. And those systems are what Liu wants to integrate generative AI with.
For a lot of the others, advanced driver assistance systems, in many cases, this is we call it AI-driven, right? So you have to develop an AI model to do that.
ADAS are already AI-driven. With the great capability of generative AI, large language models and vision language models, or what we sometimes also call foundation models, Liu wants to improve these ADAS AIs.
Shuko, I'm sure you have some examples for us.
So one of them is the image recognition technology in ADAS. So as the car is understanding its environment, it analyzes camera images, for instance. So it identifies what is visible in the camera images.
Bicycle. Speed limit sign. Pedestrian.
The AI models behind this image recognition need to be trained.
In the past, we always just detect individual objects.
Motorcycle. Truck.
And we sometimes have certain rules figure out to what the vehicle should move there.
Traffic lights.
And this is the mainstream kind of approach there. I think nowadays with foundation model we call GenAI, there's a possibility to analyze the image at a holistic way, then analyze the scenario, and then you make some kind of prediction there.
Red traffic lights with two pedestrians crossing the street in the rain. A large blue truck is waiting on the other side. A green car is waiting in the lane next to me.
Always nice to hear the inner monologue of a machine. It all starts at the very beginning of building this image recognition AI with the training data.
And that's always the crux, right? You need a lot of training data and good quality training data to make sure the system learns what it's supposed to learn.
And what we actually need is labeled training data.
Exactly.
In the past, when we develop AI model, you need to have the data, and most important, the labeled data, right? Is that you do the manual labeling for label these objects, the image, label even the 3D bounding box of the object you want to detect, because this is serve as ground truth, so that you can using that to optimize your AI model so that they can work perfectly during runtime, right? When we deploy to the vehicle.
And now you can outsource that tedious labeling task to an AI?
Well, that's basically the first step in Liu's plan, and he calls this auto-labeling.
Now with foundation model, with GenAI, you can just take some kind of unlabeled image. You can just label certain objects and also tell you what kind of object it is. You can automatically generate the boundary of the object, we sometimes call it, and also understanding what kind of object, even the parts of it. So we call this semantic segmentation, or we call it open world semantic segmentation.
Semantic, hinting at the fact that there are language models involved here. But what exactly is their advantage when it comes to labeling images?
So basically, language models are typically much more complete. So image models have gaps, and language models can fill those gaps. because language models can be trained on a much broader set of data.
But the text, there's a lot of many kind of words, right? So, we will try the large language model. We can somehow eliminate all the articles and also the books in the internet or whatever. You can train this. So we can see a whole lot of things there. But when you do the image, right, it's very hard. You cannot just collect a huge amount of image and describe all kinds of phenomena, objects in the world. Because, this is impossible.
So something that an AI trained on images might never have encountered, a language model might be familiar with.
What's that?
Seems to me like a car that looks like a hot dog.
If you say so, I'll believe it.
So in a way, these AIs can learn from each other. You combine the power of both language and vision.
And it seems like the smart thing to do. That's why in practice, they do indeed get combined into what the scientists call vision language models. So these vision language models can label training data more consistently than humans can.
And then this training data can be used to train the actual AI model for ADAS, for advanced driver assistance systems.
And that's another part of the work that Liu and his team do, with its own challenges, of course.
This is the harder part.
Using AI in a driving environment is not an easy thing to do.
But we wouldn't be talking to Liu if he hadn't figured it out yet, right?
Obviously, he and his Bosch Research team have come up with solutions. And they'll present these solutions at the most important scientific conference for computer vision this June. But Liu has a little sneak peek for us.
You want to have a structured kind of output, right? So this prompt also defines certain format. We want this kind of vision language system to take
a prompt.
Yes, just like with other generative AI systems, you can use a prompt to steer it.
The prompt saying, okay, this is my car. Then for different scenario, you can turn left and right there. And then a lot of things in this description should be common, should be consistent there. But only the status going to have some changes there. So when we do this kind of prompt, we allow certain things to change, but the certain things should be stay the same, for the different kind of data.
Think of this prompt as a kind of fill-in-the-blank exercise. So the structure of the prompt stays the same, but some words can change depending on the scenario.
Got it. And just to be clear, this is not the kind of prompt where you ask the model to do something. This is the kind of prompt you use, as you said, to steer the model, to set it up in a certain way.
Exactly like that. So when you tell a chatbot, you are an 8-year-old child, and then it starts behaving very differently, Liu's prompt limits how the model interprets given scenarios.
And prompting is definitely a skill that we all had to acquire over the past year and a half or so, right? Like, how do I talk to this thing so that it's actually giving me the outputs that I'm looking for?
Well, you said it yourself. I still have difficulties with this prompting, and depending on the tools that you use, it can be quite challenging to get it right.
Well, as usual, some people are becoming prompting experts. Also, did you know that prompting has actually become evening entertainment for some?
Okay. Can you tell me a little bit more about it?
Let me introduce you to the concept of prompt battles. It's like rap battles, but with prompts. 2 contestants are given a task and have to generate an image based on that.
I'm still not seeing it. Can you give me an example?
Okay, yeah, always examples here. Maybe take this. Create the cutest image of all time.
Okay. And then it's about who comes up with a prompt, probably, that produces an image of cuteness overload?
Exactly. Should we try it?
A prompt battle?
Prompt battle.
But let's make it audible. I mean, this is a podcast after all. Let's use a music generation AI.
Okay, that sounds really good. I'm going to add an additional idea. Let's try to create the most epic theme song for a tech podcast.
I love it. I absolutely love it. Okay, all right. Let's take a minute to each come up with a prompt.
Okay.
All right. Time's up. Hands up. Off the keyboard. Shuko, what's your prompt?
So I totally misunderstood a little bit the exercise. Oh, okay, I'll be fully open. Biker, likes to game and travel and eat.
Do you notice how she immediately took it to describe herself?
I got distracted.
It's a good prompt. And I'm sure the output is going to be wonderful.
Okay, because now you're making fun of me. What were your prompts?
My prompt was industrial metal / heavy alternative, lyrics about IT, code, technology, data security. And the title main hook is, I am wowed.
Okay. So in German, I'd call you a Streber.
Streber. I like that word. It's a good one.
It's a goody two-shoes.
Teacher's pet.
Teacher's pet.
Teacher's pet is a Streber.
Yeah.
Ladies first.
Okay, well then we'll start with my song because it has nothing to do with the podcast.
In a whirl of motion, hearts are racing.
Go, Geoff. Put your hands up.
Better dancing than I did at CES, right?
The ride is endless. I seek some adventure. Quest for thrills. For now, so pedal.
That is phenomenal.
Well, the beat is at least.
Top 10 charts, here you come.
I just want to precise, it's not me singing, just in case there's confusion.
I don't believe you.
It's fully AI.
I choose not to believe you. Okay, would you like to hear mine?
Of course I would.
Let's do it.
Oh, God.
Oh, yeah.
Why does the circus steal my gaze? Every click, every bite invites a new phase. Algorithms crawling up the data flow. Compile the code that makes the digital grow. Why?
I'm so glad that the listeners cannot see my face.
I wish I could see mine because I am absolutely wowed.
I know you are. I could see you headbanging the whole time.
What did you expect? It was perfect. I loved it. I truly love it.
I would say maybe the lyrics will take yours and you're a clear winner in the lyrics department, but I would say the beat is definitely on mine. I won with beat.
Good thing that's subjective.
Both of us are on first place.
I will share the podium with you.
But in all fairness, I still prefer our actual human-composed theme song, to be honest, so...
I absolutely agree with you. I do wish it was a little longer, but you know what? AI can actually help with that too. But in the interest of time, maybe we do it on the side.
Yeah, sure.
Okay. And if this becomes a thing at, bars in Berlin or New York, I'm also happy to take all the credit for it.
You definitely deserve it. I'll be shouting also on the roof, did you hear about prompt battles? Oh, Geoff told me. Geoff definitely did. So going back to topic, the idea of using AI to extend our theme song, I've seen something similar recently. Upcoming video generation models also have this capability. You can show them an existing video and they can make it longer. So I wonder, could this kind of thing also be used in ADAS? If the car could extend the video stream of its camera into the future, that could be used to make predictions about the traffic situation or how other agents, such as other vehicles or pedestrians, might act, and ultimately influence the car's decision on what to do next.
I think definitely I see possibility there because we also have a prediction module, right? Prediction module predict how the other agent is doing based on the current status of the agent, like pedestrian, cars, and the speed there. And now with this kind of advanced model, we can predict this behavior. When we predict the behavior, is if this is more reliable, it's definitely going to help there.
But Liu says the video generation models need to become much more reliable and much less resource hungry before they can be used for ADAS. So ideally, they would also extend their capabilities beyond just one camera view.
This is only just one video view there. But for us, you're probably going to have multiple cameras there. You need to generate the image sequence that are consistent to each other, or we fuse everything in 3D, and then also predict how the 3D world gonna change for these different agents there.
That sounds super fascinating, but also super complex. And as we know, embedded systems have their limitations. So, sorry to say, but I personally doubt that anytime soon cars will have the necessary compute power to run this kind of 3D modeling AI in real time.
Yeah, and I don't think you need to be sorry because you're probably right. And this is not only true for future three-dimensional prediction engines, it's already true for the large language models and vision language models that Liu's team is working with. They don't really run on car hardware.
They try to incorporate a lot of all the knowledge in the world. That's huge model, billions of parameters, huge size. And how are you going to fit this into this kind of platform? This is one challenge we have addressing there.
Maybe there can be a smaller version. Perhaps my car doesn't need all the knowledge in the world. It's really not relevant for the driving task to know who's the current Chancellor of Germany.
Or who the first female road tripper was.
Greta Benz. Oh, sorry. We're not doing a pop quiz right now. Sorry, continue.
Yeah, I know. I usually have always a quiz for you, but not this time, sorry. Scaling down a big model to something smaller is a nice idea, but there's always a chance it might not work as well as before. So Liu and his team came up with a different solution, a plug-in solution.
I think this is the beautiful approach called the vision language plug-in kind of approach. Basically, on one hand, you can enjoy the benefits about this vision language model and trying to bring some of the knowledge from this model to our driver assistance kind of system there. On the other hand, you don't have the hassle that you have to think about how do we squeeze the big model to fit in the platform. We can still using the existing tech stack there without changing your architecture that much.
Also, this plugin is exclusively meant for the training phase of the ADAS algorithms, so it won't be deployed in cars at all. This means thanks to the plugin, existing ADAS systems can get smarter without introducing any overhead during runtime in a real-world deployment. Liu says the vision language plugin can help improve all components of an ADAS loop: perception, prediction, and planning.
This kind of plugin, you can plug in anywhere in this kind of pipeline.
So during training, ADAS gains some world knowledge from the large vision language model, but perhaps only the kind of knowledge that's relevant to the driving task. What's the result? Does this actually improve automated driving?
It actually does, to a surprising amount. So here's how Liu's team tested this. It's a little bit complicated, but I promise you it will make sense. So first of all, they did not test this on an actual car.
Okay, so then we're talking about simulation results.
Pretty much. They used a way to simulate this that is also used by other research groups. So they can compare results in a true apples-to-apples comparison. And what they did is take data from two cities, Boston and Singapore. And they used only the Boston data to train the system.
All right, so the system should know all the things to expect in a typical North American city.
And then we apply such system into Singapore, right? This is a completely different city, Asian city, and also the view is very different. And more important, Singapore, this is a left side drive there.
Ah, yes, they drive on the left. I was trained to drive in North American cities. I don't know how well I would do in Singapore, to be honest.
Well, you'll probably get used to it quite quickly. So, fun fact, I actually took my driver's license in the UK. So, I learned to drive on the left side.
Explains a lot.
So, this Boston train system, how well does it do in Singapore? And Liu's team compared it to another state-of-the-art system for ADAS and automated driving. Here are the results as shared in their research paper.
Our solution can improve the performance by 50%. 50%.
Wow. Just to be clear, simply, in quotes, by using a large vision language model, automated driving or ADAS systems that use this kind of plugin can get about 50% safer than they were before.
In the lab. These are research metrics.
Right.
So, however, very promising research metrics.
This is also one indicator to show that whether or not your system has the capability, has a strong reasoning capability, has the strong generalization capabilities to handle all kinds of scenario, which you not necessarily see before.
Foundation models, so large language models and vision language models, are a first step towards artificial general intelligence. And through the plugin from Bosch Research, their generalization and reasoning capabilities get integrated into advanced driver assistance systems.
It's like before, visual recognition systems identified objects separately. Now, with a large language model or vision language model running in the background, it seems as though they can figure out if and how all the objects are making sense together.
So in general, bringing vision language model, or in other words, bringing in more common sense, bringing in more reasoning capability for such a system will definitely help reduce the burden of our driver a lot, because that can definitely enhance the degrees of automation about such kind of system there.
This is cutting-edge research. When will it actually be implemented and enable new ADAS functionalities and help further automate driving tasks? Well, I'm confident to say that the Bosch research team and Liu are working on it.
So this is, I'm just in the one approach to addressing this, but I believe there's even more kind of approach going to come. We're also working on other kind of approaches to addressing this challenge in the meantime. So yeah, that's pretty much the status quo.
Sounds like Liu has more exciting research waiting to be published.
Maybe he'll be back on the show a third time.
Third time's the charm, as they say.
That's right. Third time's the charm. I'd definitely be up for it. Because for me, this has been one of the more fascinating episodes we've produced.
Mm-hmm.
I mean, who would have thought that a large vision language model can help better automate driving tasks? I personally still find it very surprising.
And that's because it is surprising. Like, we have all been surprised by the capabilities of generative AI. And I think Liu's team's research only illustrates that we're at the very beginning of understanding what these systems can do and how they can be used. And I mean, beyond writing emails or generating just okay Geoff type of prompting music.
Fair enough. And on that note, let's bring in a new AI extended theme song as we say goodbye to our listeners.
This is really cruisy music. We could have had this in our last episode when we were cruising in our digital vehicle. I'm really having like the image of Geoff with the hand on the wheel extended like this on like a bouncing vehicle.
This is 90s hip hop.
Bye, listeners. I hope you enjoyed the show.
Thanks for listening.
From know-how to wow. The Bosch Global Podcast.
This is Geoff's voice avatar. The next deep dive episode is coming up. We'll have more details about how the Vision Language plugin for ADAS works. It's all about mapping, but not the navigation system kind of map. Find out more very soon on this show.